When dealing with underwater scenarios, there is a lack of simulation systems and realist 3D interfaces that allows us to remotely control tasks undertaken by autonomous and teleoperated mobile manipulator robots. The use of robots in hazardous scenarios is sometimes essential, especially in the case of accident, fire, smoke, radiation or deep waters, since it would be virtually impossible for a human to directly access these environments. Given this situation, researchers from the Interactive and Robotic Systems Lab at the Universitat Jaume I of Castelló have developed a software that allows the operator to control underwater robots remotely. The improvement involves the enhancement of the reality received from the robot, which has been placed in the hazardous environment, and unifying it with 3D information extracted through artificial intelligence techniques, thus obtaining a mixed reality which is very useful for the user. As a result, we have underwater robots with the ability to manipulate, carry out orders from a human operator, simulate the effects of robotic actions before they happen, and enrich the information offered to the user, which makes supervising tasks easier and improves safety. With this system, the state of the robot in the 3D environment can be represented, obtaining data from the actual robot about the position of the vehicle and the manipulator arm, as well as receiving information from cameras and sensors. The user interface incorporates a realist simulation system in order to trail its functions with robots and simulated telemetry before interacting with the actual systems. This user interface has been developed during the TwinBot project and tested in real-life conditions with the two G500 vehicles in the Research Center in Robotics and Submarine Technologies at the Universitat Jaume I. Besides, the software has been improved and adapted to underwater environments with industrial pipes during the first 6 months of Project H2020 Alpeace Tolero. With this system, the robot does not substitute the human, but it enhances their potential, since the robot gives the human operator the necessary tools to safely work in hazardous environments. The main goal is technological progress in the context of intervention systems, in places where the access of an expert could be difficult or even impossible, underwater or radioactive environments, etc. The assistance of the right robotic system extends the expert user's knowledge and skill to inaccessible environments for a vocation of service to humanity.